Good afternoon.
Good afternoon.
Afternoon, sir. Good
Good
afternoon, sir.
afternoon.
Good afternoon,
Good
sir.
afternoon, sir.
Good afternoon, sir.
Good afternoon.
Good afternoon, sir. Good afternoon, sir.
Good afternoon.
Good afternoon. Good afternoon, sir.
Good
Good
afternoon.
afternoon, sir. Good afternoon.
Good evening.
sir.
Good
Good
afternoon, sir.
afternoon.
Good afternoon, sir.
Good
Happy Sunday.
Thank you. Thank you.
Thank you, sir. Wish you the same.
Good afternoon.
Good afternoon, sir.
Good afternoon.
One more.
Thank you. Good afternoon.
Good afternoon, sir.
One more. Good afternoon. And then the
It's so good to see all of you here today. This Sunday, I don't know if I should say Sunday afternoon, Sunday morning, Sunday evening, everywhere around the world. Good afternoon, or happy Sunday is a better thing to say. I'm Avinash Shetty from Live Math Competitions and Leagues, and we are here today for the mental math tips and tricks session for the Grandmaster category. That's ages 12 and above. For the Mental Math World Cup 2026. I'm sure all of you are very excited about participating in the Mental Math World Cup. It's something that is going to be, around your mind for some time now. So welcome all of you. Although I'm sure you have a lot of questions about the event, how is it going to be held, what, when, where, all of this information has been shared with you on your registered email ID. Once you register, the emails that was sent to you included all these details about the competition, along with links to join the WhatsApp community groups and the study kit. So if you still have any more questions about the competition or about the study kit or about the community link, please write to us on contact@livemcl.com or drop us a message on WhatsApp on +91 8291 027238. And somebody from our team will definitely answer you and respond to all your questions about the competition. Today's session is not about the competition. It's about the mental math tips and tricks. And for that, we have someone very special, Mr. Daniel Timms, who is a world-renowned mental math trainer, as well as an expert and coach specializing in practical mental math and psychology of calculation. He's actively involved in providing workshops, trainings, stage performances, and training material for mental math, including international competitions. Daniel also runs the World Mental Calculation website, offering news and resources for advanced and competitive mental math. Apart from that, he also competes in mental math competitions around the world. He's amongst the fastest, calendar date calculators for UK. So it's a privilege to have him here with us today, and especially here for all of you. So make the most out of this session. I hope you have a pen and paper ready. Over here, we are not here to just, Daniel is not here to teach you the basics of mental mathematics. He will show you the psychology of it, how the way to think about a problem and how to go about solving it. So normal school math is obviously something that you've learned your abacus and all of that, but there are still other ways to think about how to solve these problems, and Daniel is here for that. I would appreciate if you focus on that. Make sure you have a pen and paper ready and make the most, document everything. Obviously the recording of this session will also be available with you tomorrow. So, if you still happen to miss something, you can catch up on it again later. Daniel, with that said, I think you have the stage now.
Well, thank you very much, Avinash, for the introduction. And very nice to see all of you joining the workshop today from all around the world. I'm curious where people are from. If I invite you to send a message in the chat, just to tell me which country you are joining us from today. Me, for example, I'm from England. I'm joining from Oxford in the UK, where I spend the summer. And just to expand on the introduction that Avinash has kindly shared. So yeah, this is the workshop for tips and tricks and tips for mental maths, specifically for the things that you need for the Grandmaster and Zen Master levels of the Mental Math World Cup that's coming up. I'm Daniel Timms. Kind of introduction to me. I'm from the UK. I did mathematics at university. I worked as a software developer from 2012 after I finished university. And then I decided I was going to travel. So since 2016, I have been moving between places quite a lot, staying in several different countries each year. And one of the reasons I started was because I was going to a competition in Las Vegas. And I thought I don't want to go there only for this. I want to make a bigger trip and visit other places. So so mental maths has also been a part of my travels. I've been several places around the world to compete in mental maths, and you'll be aware that live competitions and league, they offer competitions online as well as in different places around Asia. And so in the last years, I've concentrated a lot on mental maths. I have the World Mental Calculation website that some of you may have seen. It's like
to use facial recognition instead of repeatedly showing admin, can you please mute everyone? Documents. According to the
Thank you. So I have the World Mental Calculation website, which is where I publish a lot of resources about mental maths in general, especially advanced methods and sometimes interviews with calculators, things like this. And I'm also a mental math coach at events such as this one, which is why I'm here today. Today we're going to cover exact square roots, multiplications, divisions, addition and subtraction, here thinking more about the psychology and not the method because these are quite basic, highest common factor and lowest common multiple, and starting with exact cube roots. So these are the main topics that I'm going to cover today. And multiplication and division, this also includes percentages. I've got lots of messages from people about where they are in the world. So where do we have? We have from India, from Delhi. We have more from India, from Romania, from India, from the UAE, from Bangalore, South Africa, more from the UAE, other cities in India, many people from India. India is always very strong for mental maths. A lot of people from Dubai as well, or other places in the UAE, from Bahrain, more people from Bahrain, Fujairah, I think that's in the UAE,
right.
Sri Lanka. I was in Sri Lanka in October, actually. I was staying a week in Colombo. And more people from SA, that's either South Africa or I think Saudi, could be either.
Saudi Arabia, yeah.
Saudi Arabia, yeah, okay. More people from Sri Lanka. So mental math, you see, is a way of when you are at a high level at mental math, which is what you're all working towards now, then you get access to a more international community where you meet people from all around the world, from Europe, from Asia, from Africa, from the Americas, who are also elite at mental maths. So in the competitions that I've been to in person, again, there's people from all sorts of places around the world. Here online today, we have people from Mauritius, from Thailand. I was in Chiang Mai, not Bangkok, but I was in Chiang Mai for a few months at the end of last year. Very nice place. Germany. I've been to Germany many times for mental calculation competitions. It's another place where a lot of competitions have been organized. More people from India, and finally, more people from India. So, okay, really nice to have you all joining us here today. I see the emoji reactions with lots of flags as well. Very cool. So what are we doing today? I said we're going to start with cube roots. So I'm going to share the whiteboards and we get started.
Hey, Daniel, before you start,
Yes.
a request to everyone, if today's session will be interactive. Daniel will be asking you a lot of questions while he's going through all the topics. But when you respond to it, please respond with one response. If you give a answer, just put it once and just leave it at that. Don't keep on putting that same answer again and again, but because that clogs the entire chat, and we are not able to call on anybody else after that. All right. So it's a simple request. Please don't clog the chats.
Thank you. Yeah, we had the issue yesterday. Some people were sending the message and the response many times, and it actually means I don't find their answer at all because when I have a look at the chat later, I can't understand the message. So just send the message one time, and then I will try to include as many of you as I can during the questions today. So we're looking today, first of all, at cube roots. So what does a cube root mean? So if I tell you, for example, that 15 times 15 times 15 is equal to 3,375, another way of saying this is that 15 cubed is 3,375. So this means the cube root of 3,375, let's tab that back, is 15. So in the Mental Math World Cup and also other calculation competitions, you may be asked to find the cube root of a specific number. And for the ones that you have in the Mental Math World Cup, you know that the answer is going to be a whole number. So if you are asked to find the cube root of 3,375, you know that the answer is going to be a whole number and not a decimal. So how do we do this? First of all, I'm going to share the cube numbers up to 9 cubed. And can anyone tell me, answers in the private chat, what do you notice about the last digits of all of these? So answers in the private chat. And for this workshop, when you send me the answer to a question in the private chat, sometimes I will ask for a volunteer to explain. If you would like to volunteer to tell us your answer, then after you write the correct answer, then tell me that you volunteer. And then I will select someone at random who has the correct answer and who would like to volunteer. This way, if you want to answer but don't want to volunteer, then I'm not going to surprise you. So I will look and see if there's someone with the correct answer who would like to who says that they would like to volunteer. I've got some correct answers, but no volunteers so far.
One question.
Okay.
Yeah. How do you chat? I can't find the chat.
If I think at the bottom of your screen, if you put the mouse there for 1 second, then a little bubble will appear where a lot of options will appear, and one of them is called chats.
Oh, like when I press everyone, it says chat disabled.
You can send a message only to me. I'm Daniel
Oh,
Timms.
okay. Thank you.
Yeah, maybe that's helpful for other people. Yeah. So to send a message to me, then send it to Daniel Timms.
Thanks.
Daniel, just hold on a minute, right? Yeah. Yeah, we can move ahead.
Okay, thank you. So remember that if you would like to volunteer to explain your answer to us, then write the word volunteer in the chats. So today, our first volunteer is Retief from South Africa. So can we
Daniel,
unmute Retief, please?
Yes.
Thank you.
You said Ratif, R-A-T? You're Latif.
R-E-T-I-E-F, yeah.
R-E-T. Ratif. Okay. Got it.
Morning, sir.
Good morning. What do you notice about the units digits?
I noticed that all of the last digits all of them were different.
Good, yeah. They're in a kind of random looking order, but they're all different. Exactly, yeah. And so well done for everyone who noticed this. And this is going to help us a lot for calculating the cube roots. Next question, and this might look like a really difficult question, but what is the last digit of just the last digit? What is the last digit of this number? The answer is a really, really big number, but what is the last digit? Okay, write the answer in the chat. And if you volunteer to share the answer, then you could also write volunteer. So lots of answers, not all of them correct, but it's good to see people trying. Okay, can we invite Rayansh, please? Rayansh Agrawal.
Like one thing I noticed, which I also wanted to add, is that the cube of any number which is ending with 7, the unit digit of the answer will always be 3. So that should be the answer.
Very good, yeah. So the answer here, to find the last digit of the cube, we don't have to look at all of the other digits. We only need to look at the 7. We only need to look at the 7, and the last digit for sure is going to be the same as the cube of 7. So it's the same as for 7 cubed. Must end in 3. So the answer is going to be a huge number, but the last digit for sure is going to be a 3. And so this means, so first of all, why is this true? Some of you at school have been studying algebra, so I'll show you as a kind of bonus today why this is true. I guess I need more space for this, so boom, boom. Yeah. So I'll explain just with some algebra why this is true. So all of the algebra you're doing at school, what is the purpose of this? Well, many, many, many things. And in this case, we can show that the rules in mental maths are working. So any number that ends in 7 can be written as a multiple of 10 plus 7. So this is a multiple of 10 plus 7. Its cube is therefore going to be 10n plus 7, all cubed. And if we do the algebra on this, this is maybe a little more advanced algebra, but I tell you the answer. It's going to be 1000n cubed plus 700n squared plus 490n plus 343, which is equal to, we're going to copy and paste most of this. Actually, I'm going to post all of this. So this is 10 multiplied by all of this. Plus 3. So what I've done here is I've written the cube of any number that ends in 7 as a multiple of 10 plus 3. So this means that the cube of any number in 7, we can prove with algebra it ends in a 3. What about the cube of any number that ends in 4? Well, we can do the same thing, and then we will see that it must end in a 4. And we can do the same thing for an 8 and show that it must end in a 2. So we've got 2 things that we found today. First of all, that for the cubes, the units digits are all different. And the second thing is that the cube of the number depends only on the last digits. So logically, this means that if I give you a cube number, you can look at the last digit and see all of the possibilities for the last digit in the cube root, but there's only going to be one. So it means we know it for sure. So putting this together, we now have a rule for calculating cube roots. So if I have, I just have, to make an example here. Don't know why anyone is looking for, okay. So for example, to find the cube root of this number, step 1 is going to be find last digits, which is a 3. See which cube ends in this digit. So in this case, we know that 343 is 7 cubed, and therefore last digit must be, for example, I can't type, must be 7. So whenever you have a cube root question, the first thing you can do is look at the last digits. In this case, it would be a 3, and say which cube number from 1 to 9 ends in a 3. And you should know that 7 cubed is 343. And therefore the answer, the cube root of 103,823 must end in 7. So this is the first thing. So a question for everyone to try this. What is the last digit of the cube root of 116,786,755,072? So answers in the private chat. Okay, and for our volunteer, can we have Dash, please? Dash has the correct answer. Many other people also have the correct answer. Very good.
Darsh, I'm trying to unmute you. Can you? Darsh Mulgaonkar?
Yes, sir. Doctor, the correct answer is 8.
Good, yeah. Why is it 8? How can we be sure that the answer is 8?
The answer is 8 because the cube of 8 is 5 and 2, which ends in the digit 2.
Very good, yeah. So the cube ends in 2. It's like 512, which is 8 cubed. Therefore, cube root ends in 8. Okay, very nice. So thank you for sharing. This is exactly correct. So this is how we can find the last digit of any cube number, even if it's a really big cube root. And some people, they practice doing cube roots of 8 and 9-digit numbers, or even like 10, 11, 12-digit numbers, or sometimes even larger. And this is the first step that they can do. How do we find the other digit though? So in the example of 103,823, we also need to find the other digits in the answer. So question for everyone, can you tell me what is 40 cubed? What is 40 cubed? I write the question down so you can also read it. What is 40 cubed? Okay, can we invite Mia to tell us the answer? Mia, can you tell us what's 40 cubed?
Sir, it is 64,000. As the zeros have to end in 3 digits, and since 4 cubed is 64, it's supposed to be 64,000.
Very good, yeah, thank you. So 40 itself is just 4 times 10. So that means that 40 cubed is equal to 4 cubed times 10 cubed, which is equal to 64 times 1,000. So 64,000. So this means that for calculating a cube root, we can look at the last 3 digits, or should I say we can ignore the last 3 digits and see what the previous 3 digits are. So in this example, let's use the same color. If I remove the last 3 digits, which is 823, so I'm going to put a cross through those last 3 digits and look only at the 103, I can now compare that in blue to my list of cubes. And in this case, 103 is greater than 64, but it's less than 125. So that means that the cube root, it must be more than 40, but less than 50. So it must be 40 something. It's 40 something, but we know it ends in 7, so the answer must be 47. And so putting these together, we have a complete method for calculating the cube root of any number. And I'll do this on the next slide of the whiteboard. We can also save the whiteboard and send them to you later. So if you're making notes now, that's really good. And we will also give you the whiteboard to add to your notes later. So to find the cube root of 4, 5, or 6-digit number, and this is what you need to do for the Mental Math World Cup. If it's a 7-digit number or larger, then we have to do more things in the methods. But today I want to focus on the tips and tricks for the Mental Math World Cup. I'll also give you some information later so you can read by yourself how to find cube roots of even larger numbers if you want to study that. So step 1, we've already said, it's look at the last digits and see which cube has the same last digits. That's the last digit of the cube. I'm not going to call it step 2. I'm going to call it step A, because you can do step 1 first, or you can do step A first. It doesn't matter. You get 2 pieces of information, and those are the 2 digits of the answer. So you could do step A first, and then do step 1. So to illustrate that, I'm going to put it in this order. So step A is remove the last 3 digits. Compare these to the cubes of the digits 1 to 9. That's the first digit of the cube. So this here is now a full method for calculating the cube root of any number. So in this case, we have 103,823. So I'll draw this as an example to the side. Which color should we use? Let's do red. For example, this number. So step A. So the cube root is between 40 and 50. So it's 40 something. Step 1. Ends in 3. It's a bit like 343. Last digit is 7. Everything together, it's 40 something. It ends in a 7. Therefore, the answer is 47. I've written this in red in lots of words, but when you practice this, it's very, very fast to go through these 2 steps, get the 2 pieces of information, and then write the answer. So let's try this with an example. I'll give an example that's not too crazy. So let's try writing in orange. Example 1, cube root of 592,704. So answers in the private chat, and if you want to volunteer, you can also tell me that you volunteer. And just so you know, I'm getting like 100 messages, so it's really random whether I see your message or not. So what's the cube root of this one? Okay, first correct answer I see is from Ayan Bansal. Lots of other correct answers coming through.
So should
Ayan? Yeah, what do you
Yes,
think
I
the
am.
answer is?
So first I took the first 3 digits, 592. Now 592 is between 8 cube and 9 cube. So that means that the first digit is 8. Then I looked at the last digit. The last digit was 4, and I saw and only when it's 4 cube is the last digit 4. So that means the second digit is 4. Then you take 8 and 4, so 84. 84 is the answer.
Very nice. So it ends in 4, like 64, which is 4 cubed. So units digit is 4. And so the answer is 84. Very good and nice explanation. Thank you for that. Very good. So the correct answer here is 84. And I see in the chat quite a lot of other people also giving me the answer of 84. So if you got 84, then yes, well done. And lots of volunteers as well. Thank you very much for that. Okay, let's do one more example of the cube root. And yeah, another example for the cube roots. So in this case, I'm going to pick, I'll try a tricky one. So again, same thing, answers in the private chat. And if you want to volunteer, then write the word volunteer after your answer. So cube root of this number.
Hey, Daniel, while solving this sum, if you could also explain to the participants for the first digit, why would you choose uh, an 8 instead of a 9? Or, for example, I'm just giving you an example of, why would you choose the first digit? Which one is closer to the actual answer?
For the orange example. Okay, yes.
Yeah,
So
yeah.
we know that 8 cubed is 512. So this means 80 cubed must be 512,000. And so the number we've got is 500 and not 12, 592,000 and something. So it's larger than 80 cubed. So we know that it must be 80 something. It could be 81, it could be 88, it could be 89, we don't know. And but we know that it can't be 90 or more, because 90 cubed would be 729,000, and that's bigger than 592,000. So I'm just seeing which of these cube numbers in blue is the thousands digits greater than. In this case, it's greater than 512. Okay, for this, I've got a few different answers coming through. And so this is a bit of a tricky question, apparently. So I'm glad I gave you this one. Can I ask for Achintya? Achintya.
Yes, sir.
Yeah. So
Sir,
what method did you
so
use? And finally, we get the answer.
sir, we like keep the like when we remove the last three digits, we get a 12, which is like nearest to 8, the cube of 2. So we put so the first digit is 2, and then we use the last digit of 167, which is 7. So 7 can only be a cube of 3. So that is why I wrote it is a cube of 23.
Very good, yeah. Great explanation there. So a lot of people, they're tempted to look at the first three digits, which is 121. And then you might think it's like 125, but really it should be less, or it's more than 64. But it's not the point. In this case here, we're looking at the first two digits only, which is 12, or 012, if you like. And 12, when we compare it, it's greater than 8, so it must be 20 something, because 8 is 2 cubed, the tens digit must be 2. It's not as big as 27, so it can't be 30 or more. And the last digit then is the last digit is, what is it, 7, therefore ends in 3. So the answer is going to be 23. So I think that's trick quite a few people, but it's really important to not be tricked by this, because in the Mental Math World Cup, you will have cube roots of 6-digit, but also 5-digit and also 4-digit numbers. And so important to get those right. Because I got so many different answers, I want to do one more example of this before moving on. So example in brown, then I just get the value on my calculator. Okay. So what is the cube root of 582? Sorry, 5832. Okay, correct answer from Aisha Hamad. Can we have Aisha Hamad to share, please?
Yes.
Yeah. How did you solve this one? You got the correct answer.
First, I did step 1. I looked at the last digit and it was a 2, and the 2 came from the number 8. And then I looked at the first number after removing the last 3 digits, it was a 5, and 5 was just above the number 1. So the cube number is 18.
Very good, yeah. So when we take the 3 digits away, we're left only with 5. Not a 3-digit number, not a 2-digit number, just a single-digit number. So when we compare this to the cube numbers, then it's between 1 and 8, it's above 1. So between 1 and 8, so it's above 1. So the answer is going to be 10 something. It's going to be 18. So also notice something here. Aisha did step 1 first, and in the previous examples, we did step A first. Which one is correct? It doesn't matter. You get the 2 pieces of information in whichever order you want and solve the question. So this is a great illustration, actually, solving the question using the same method, but doing step 1 before step A. Thank you for sharing. So this is everything I want to mention, I think, about cube roots. So we've done some examples of the standard method that works for any cube number where the answer is 2 digits. If you want to do cube roots of greater ones, then you have to do some extra steps that makes it more difficult. You don't need that for this particular competition. We also proved mathematically that this rule works, which we don't need to prove it when we're solving, but it's nice to see why this is true. Okay, so that's everything I want to cover with the cube roots. So now let's move on to the next topic, which is going to be the exact square roots. So exact square roots. So what does it mean if I have 45 squared? This is 2025. Well, this means 45 times 45, which is 2025. So therefore, square root of 2025 is 45. So this is just what it means. Hopefully you all know this. If you didn't, then you discovered this today. So it's like cube roots, except in cube roots, you have the number multiplied by itself 3 times. For square roots, it's like a 2-dimension version, so it's only multiplied twice. So how do we do this? Well, let's try to do it the same way as the cube roots. So we can look at the last digits and hope that they're all the same. And we can look at the first digits and figure out the 2 digits this way. And when we try this, we see that it almost works, but not quite. So I'll show you how I would try to do the methods for, let's say, square roots of 3,364, and then you'll see what's going wrong. So step A is I take away the last 3 digits. No, not the last 3 digits. That's not going to work. Because you see, if I have 50 squared, this is 2,500. I've only got 2 zeros at the end from the fact that it's 50, not 5. Again, I can have 60 squared. This is equal to 36 with 2 zeros. So need to remove last 2 digits only, not the last 3 digits, the last 2 digits. So in step A, 3364, I've got 33, and then I'm removing the last 2 digits at the end. Compare 33 to square numbers. So 25 is greater than or equal to, so is less than or equal to 33, which is less than 36. Therefore, the tens digits is like 5 squared equals 25. So the answer is 50 something. So step A is working the same, except that I don't take away 3 digits for a cube root. I just take away 2 digits for the square roots. So far, we know the answer is going to be 50 something, but we're trying to find out what the last digit is. So the last, let's say step 1, last digit is 4. This is like 2 squared equals 4. Therefore, the answer is 52. Answers in the private chat. What have I done incorrectly? What is my mistake? Put a big cross here so you understand. This is incorrect. Can I have a volunteer to explain what have I done wrong? So tell me the correct answer and then the word volunteer. Okay, can we have Yat Him Chan, please? Yat Him Chan.
It's you are incorrect because 8 squared is equal to 64, and 64 also has a 4 at the end.
Good, yeah, this is exactly right. So this is like 2 squared, or it's like 8 squared equals 64. So from this information, I don't know whether it's 52 or 58. And actually, it will be 58. So for square roots, you have the problem that when you look at the last digit, there's usually 2 possibilities, and you need to do some extra thinking to decide which of these it's going to be. So how to decide whether it's small, 52, or large, 58. You always have a small possibility or a large possibility. And I'm going to give you 2 methods. So, well, actually 3 methods. So method 1 is going to be just guess if it's close to 50 squared equals 2,500. Therefore, it's going to be the small option. I have too many things on my screen. I can't see what I'm doing. Okay. If it's close to 60 squared equals 3,600, therefore it's going to be large. So when I say small, that means it's going to be the 52 option. If it's large, it's going to be the 58 option. So sometimes you can basically just guess. You can say, well, in this example here, 3364 is very far from 2,500, but it's close to 3,600. So if I just guess it's going to be the large one, then clearly I'm going to be correct. So to be clear, this is 3364. Like this. And one thing I've noticed in the when I've been coaching groups in mental calculation, that students from Asia often don't like methods that have guessing. You want to have a specific algorithm that tells you the steps for sure, whereas people in Europe are more happy with methods that involve a bit of guesswork. So I show you a few different methods, and then every person can choose which method is making most sense for them. So method 2 is compare with 50 times 60 equals 3,000. So in general, get the tens multiplied by next tens. So in this case, we know the answer is in the 50s. So we say, what is the tens after 50? It's 60. So I do 50 times 60, or just think of 5 times 6. And that gives me, this gives me 3,000. So to be clear, I'm looking at the 5 times 6 and comparing it to 30. This is the same as doing 50 times 60 and comparing it to 30. If our square, so if 3364 is larger, then it's going to be the large example, like 58. And if it's smaller, then it's going to be the small version, which is 52. In this example here, clearly now we have the answer. With method 1, clearly it's going to be close to this one. Sorry, clearly it's going to be close to 3,600 and not the other one. And here 3,364 is certainly larger than 30. So it's, again, we see it's going to be the large one. Also to point out, we don't care about the 64 here. I can do this just looking at the 33. So this is method 1 and method 2. I'm also going to show you a method 3. And this is the easiest one, but you need to prepare a lot, which is just memorize all the squares up to 99 squared. If you do this, then you know the answer. You don't need to do any calculation. You see 3364 and you say, yes, I know that's 58 squared from memory. And then you don't need to do a calculation. So these are the alternatives for finding the last digit when you're doing squares. If you feel confused by this, I recommend method 2. If you know some of the square numbers, then maybe learn the rest and do method 3. And if you feel confident with comparing numbers, then you can just do method 1. All of them very easily get you the correct answer. So let's try using method 1 or method 2. If you know all of the square numbers, then see if you can figure this out using method 1 or method 2. I'll put an example on the board. So example is going to be square root of 7744. So answers in the private chats. What is the square root of 7744? And if you want to explain your method to the group, then write volunteer afterwards. Okay, I've got some answers coming through. Can I invite Kabir, please? K-A-B, Kabir.
Hello. So the
Hello.
answer is 88 because 77 is close to 64. It's bigger than 64 and less than 81. So I know the first digit, the tens digit will be 8. And then I take 4, which is the last digit. So I know the last digit is either 8 or it's 2. And I took method 1, so I just guessed because it's closer to 800 than it is to 6,400. I took the bigger option, which is 88.
Good, yeah. So when we do step A, we can recognize that not only is this 80 something, but it's 80 and a big number. So the units digit is large, and therefore, if I got this correct, yeah, units digit is 2 or 8. So method 1, choose the large option. I'm running out of space. Units digit is 8, so the answer is 88, which is correct. Cool, very good. Perfect explanation of how to use method 1. Very nice. Let's do another example, and I want to show both methods. So for this one, try to do method 2. So for this one, I'd like to know the square root of 676. Is that what I want? Yeah, 676. Okay, can we invite please Chetan Dev Patodia? So CH, Chetan Dev Patodia.
The answer will be 26. And
Yep. And how do we
so
know?
I remember this, but I'll state the method also. So it ends with 6, right? And we know 25 square is equal to 625. So we can conclude that at the end there'll be a 6. And 6 comes between 2 square and 3 square, that is 4 and 9, and so therefore it can be 26.
Good, yeah. So if here, when we remove the last 2 digits, we only have the first 6 left. So answer is above. So the answer is between 20 and 30. And can you repeat, please, how did you figure out the last digit? We know it must be ending in a 4 or ending in a 6, but how do we know whether it's 24 or 26? Maybe we need to unmute Chetan again.
So I figured it out because 25 square is 625, and since it's more than that, it'll be 6.
Okay, good. So for method 2, what I would suggest for this is to try, actually for this I need, so I would do 20 times 30 is 600. Greater than 600 means large option, so it's going to be 26. And what Chetan has done is slightly different. It's like method 2, which is 25 squared is 625 from memory, or maybe you calculate very quickly. So it must be greater than this. So we have a slight variation here, which is also, yeah, a perfectly good way of doing it. So that again, it needs to be 26. So comparing it to a value that you already know. Okay, very good. So this is everything about square roots. Well, most of what's is this the main method for square roots. So it's like cube roots that you get two pieces of information from different digits in the question. Partly you look at removing the last two digits, or for cube roots, it was 3 digits, and this tells you what the tens digit is for the answer. And when you do this for very large calculations, you can do this to find whatever is the first digit on the left. For the ones we need for the Mental Math World Cup, the answer is 2 digits, so this will tell us the tens digits. Then we have a look at the units digit to see what are the possibilities. And for cube roots, we knew immediately what the units digit must be, and we're finished. For square roots, it's actually more difficult because there's usually two possibilities. And when there's two possibilities, you have to decide, is it the big one or is it the small one? There's always one of them less than 5 and one of them greater than 5. And so you can do this by method 1, just by feeling it's obvious from guessing by the size of the numbers, or you can do method 2 by multiplying the tens digits by the successor of the tens digits and then comparing those. And if you happen to know the square of the number in the middle, so 25 squared, you could just use that. That's also possible. And the other thing you can do is if you've just memorized all of the square numbers, then you already know the answer. So these are the methods that we can use for calculating square roots. I want to show you though a little bonus, which is what I use for calculating square roots of very large numbers. You see, for the square root of 3,364, I know just from looking at the 64 that the last two digits are either going to be 08 or 58 or 42 or 92. And I'm going to show you a little algebra bonus, which allows me to do that. So rule for last two digits of a square number. And this is useful for calculating the square roots. And again, this is a proof using algebra. So first, I'm going to do an example. So we just did 26 squared was equal to 676. Answers in the private chat. Can anyone think of any other numbers, any other square numbers that end in 76? Are there any other square numbers that end in 76? So answers in the private chats. I don't need volunteers for this one. You can just type the number. Okay, so Vihan has found 74. Let's try this. So 74 squared is equal to 5476. Yes, okay. So this one works. Which other ones can we find? So Chetan has found, who already explained one for us before, has found also 24 is equal to 576. So there's three numbers whose square ends in 76. Are there any more? Does anyone know any other ones? 126, yes. There is actually another one, which is a two-digit square. So a lot of people finding 24, very good. There are some, there is one more. There is one other one. I'm curious if anybody will find this. Yeah, very good. So Vihan got there first. So this is 7, well, Maybe other people did, but the first one I see was 70 Vihan, who found 76. So well done everyone who found that. 5,776. And then really I only care about the single digit ones, but we also have 124 squared, which is, I guess I should try and do that. 148, 1, 5, 3, 7, 6, 52, 1, 5, 8, 7, 6. Okay. So does anyone notice, actually, let's do another one. So another example. So 11 squared is equal to 121. Any other square numbers? I'll stay with two-digit ones. Any other two-digit square numbers that end in 21? Again, answers in the chat. And then for this question, I don't need volunteers. How many can we think of? So again, I still have Vihan's chat window up. Vihan found 39. Very good. So 59 squared is equal to 1521. Which other ones might we find? Ethan has found 61. Maybe some other people also told me 61. Good. So this is going to be 3721. Are there any others? Can anyone think of any other ones? Yeah, and Kenichi has found 89. And that's all of them actually. This is everything. Which is 7921. So next question, and for this one, I will accept a volunteer. What is the pattern? What do you notice about the four numbers whose squares end in 76 and the four numbers whose squares end in 21? There's a special pattern. And so at the moment, this mathematics is like guesswork. You find some examples and you try to see, do I notice a pattern? Is there a pattern between these digits? Okay, I'll ask Hamdan. Hamdan is our first volunteer for this. What do you notice about the patterns?
Sir, like there is 50 plus, like 24 plus 2 is equal to 26, and 24 plus 50 is equal to 74, 26 plus 50 is equal to 76, 74 plus 50 is 124, 76 plus 120 plus 50 is 126. So we can notice this pattern like plus 2 plus 48 plus 2 plus 48 and plus 2.
Okay, and so yeah, interesting point here. We have the 24 plus 74 is like 24 plus is 50 plus 24, and the 76 is 50 plus 26, and then it keeps increasing. So here we have like 100 plus 24, 100 plus 26. So now we can imagine maybe it's true that the next ones would be 174, 176, 224, 226. Is that pattern working for these ones?
Yes, sir.
So,
But sir, here there's a different pattern. 11 plus 28 is equal to 39. 39 plus 22 gives 61. And then again 61 plus 28 gives 89. And so the next in the pattern is 89 plus 22 is equal to 111. So this will give a number ending with 21.
nice, yeah. So we have a kind of regular pattern that's appearing here. And so every 50, you end up adding, making two jumps, and then you're 50 ahead. There's a pattern even deeper than this. So I'm gonna see if we have um, any other volunteers who asked to share. Maybe I can get a couple of different ideas for this because there's quite a lot happening. So I'm just checking uh, yeah. Again, can I repeat? When you send me the questions, don't don't answer multiple times because then I it's difficult for me to know whether um yeah, it's difficult for me to know what you're actually responding to. Okay, I'm sure there are some volunteers, but I'm not finding them quickly. Okay. Maitreya, you had the same thing you explained to me very well. Nice. Um, Maybe could we have Mia? If we ask Mia to volunteer, do you have, maybe we already mentioned what you had to say, but do you have anything else you'd like to add here to Mia?
Sir, for the pattern I have noticed is that like the ones digit for 76 for the ones ending in 76 is either 4 6, and for the one in 21 it's either 1 or 9.
Um, I'm not sure I understood actually. Can you explain again, please? Sorry. Or did we already mute Mia? I think she's still talking.
I'm trying to unmute her. Actually, I don't know how it mutes
Okay,
her
allow.
specifically. Yeah.
So for the pattern I have noticed is that for the numbers ending in 76, since the last digit ends in the sixth place and six, the last digits of the numbers for the square roots either end in 4 or 6, and then for the 1 and 21s, it either ends with 1 or 9.
Good, yeah. So we can see how these arise as part of what we talked about before with the step where we find the units digits. Very good, cool. Thank you for sharing. I'm going to show you something else, something additional here. So 26 is like 50 minus 24. And this here is like 100 minus 24. And this here is like 150 minus 24. So we have 24, 50 minus 24, 50 plus 24, 100 minus 24, 100 plus 24, and so on. And we have the same thing here. So this one here, it's 50 plus 39. It's also 100, well, that's the cool symbol, 100 minus 11. And this here is like 50 minus 11. And this pattern always works. You always have a number, one option, which is less than 25. And then you have 50 minus that, 50 plus that, 100 minus that, and 100 plus that, and so on, carrying on forever. So let's do a final example with this. So if I have, for example, 12 squared equals 144, can someone tell me all of the numbers, all four of the numbers whose squares end in 44, all of the two-digit numbers? Uh, Thank you. Yeah, there's a Thank you for correcting me. Yes. Okay. And if you found all of them, then tell me you volunteer. Okay. Okay, so we have a correct answer from Sanintha. Sanintha from Sri Lanka. You found all of the other ones after 12. Yeah, Sanintha.
Good afternoon, sir.
Good afternoon.
So the other two-digit numbers where their squares end in a double four are 38 squared. And because I found out that 50 minus 12 is 38.
Good, yeah.
62 squared. Where 50 plus 12 is 62.
Very nice, yeah.
And then 88 squared. Based on the fact that 100 minus 12 is 88.
Very good, yeah. Perfect
Thank you,
explanation.
sir.
Thank you very much, Sanintha.
Thank you, sir.
So this means that if we have, let's say, if I'm finding in the red example the square root of 7744, another thing I can do is say, well, it ends in 44, it's like 144, which is 12. And so it's going to be one of these examples. It's going to be 12, 38, 62, and 88. And clearly it's this one. This is also really helpful if you want to memorize the square numbers. Because when you learn 88 squared, you know that the last digit must be 44 because it's like 12 squared. So this removes the work of memorizing by about half. You have about half as much work to do. So why is this rule working? So, um, so example with, let's do with 12, 144. So it's any multiple of 50 plus or minus, plus or minus 12. So we're looking at squares of any multiple of 50 plus or minus 12. So this would be 50n. This is any multiple of 50 plus or minus 12. And I'm going to find the square of this number. So this is when I'm using algebra. By using FOIL or expanding brackets or binomial theorem or whichever method you use for expanding the brackets, this would be 2500 n squared plus or minus 50 times 12 doubled, so double of this number, and then either plus 12 squared or negative 12 all squared. The double negative makes a positive, so this will always be 144. I'm going to do it as 12 squared. This then is equal to, I'm going to copy the same thing. This is 144, and 2 times 50 is 100. Now I can do the factoring, and this is 100 lots of 25 n squared plus or minus 12 plus 144 equals a multiple of 100 plus 44. Therefore, ends in 44. So this here proves that any number if I have 50 plus or minus, sorry, I start again. This proves that if I have a multiple of 50 plus or minus 12, which are the examples that Sanitha just told us, then the square of that number must end in 44. And we can apply the same logic, not just for 12, but for any other number. I'm going to copy paste. I'm going to change the color. So example, if I have any multiple of 50 plus or minus x, where let's do that, plus y. So y can be any number. Then I just replace this. This is going to be y here and y squared, like this. This is going to be some multiple of y. It's a different multiple of y, actually, doesn't matter, plus y squared, which is a multiple of 100 plus y squared. So same last two digits as y squared. And because my text is all running into each other, I'm going to delete that. So this proves it now for all numbers, for all of these patterns. So, okay, what have we done here with square roots? So first of all, we saw that we could do a method like the cube roots, but for square numbers, but the units digit, we had two possibilities. So we needed to have some methods, and we have a couple different options here for finding what the last digit would be. Then we have method 3, which is just memorizing all of the square numbers. And so to help us understand the structure of the square numbers, we have a look at the last two digits, and we can use algebra to prove that the rule is true, that the numbers with the same last two digits always fit this pattern. Multiples of 50 plus or minus whatever amount. The example with 12 is you've got 12, 50 minus 12 is 38, 50 plus 12 is 62, and 100 minus 12 is 88. So if you're looking for a square number that ends in 44, if you find one of these numbers, then you can easily find the others. That brings us to the end of what we're doing with the cube roots and the square roots. I think, Avinash, you wanted to have a short break.
A short break, that's right.
So should
I
we have
think
a
this is an
short break
opportune time.
until 5 p.m.?
Yes, let's
Break
do
for
that.
7 minutes.
Let's do that. Let's have
Okay.
a short break and circle back again.
Okay, yeah. So everyone take a little breather for a moment, and then please be on time, because we will already be starting at if you're in India, this will be 5 p.m. And if you're in other countries, it will be 30 past the hour. So at half past the hour, then we start again, which is in about 7 minutes time. Okay, welcome back, everyone. We're going to start in the next 30 seconds. To begin, I've put a little question on the screen. I have a really big multiplication, and I want to know what would be the last digit of this multiplication. Okay, let's have Tobechi or Ragwu. Tobechi, please. Lots of correct answers coming in. Okay, I think everyone finds this question quite easy. Tobechi, what was your answer and why do we know it's true?
So my answer was 4 because if we take the last digits of these two numbers, which are 3 and 8, and when you multiply them by each other, since the other digits after they don't really matter in this case. So 8 times 3 will be 24, and so that means that the last digits of this equation is going to be 4.
Very good, yeah. It's exactly like this. You just need to look at the last two digits. And just very quick algebra, if anyone wants, we have some multiple of 10 plus 3 multiplied by some multiple, a different multiple maybe of 10 plus 8. And if I multiply the brackets, I end up with 100 and m plus 30 m plus 80 n plus 24, which is equal to basically the first three numbers is multiples of 10. So anything that isn't just the 3 and the 8 is a multiple of 10. So nm plus 3m plus 8m plus 2. And then with the 4, well, let's just remove that, plus 24. So therefore must end in 4. So this is a trick that can help you with multiplications that even without doing the full multiplication, you can look at the last digits, which the last digit of the two numbers you're multiplying, and that tells you the last digit of the answer. So what we learn here look at the last digits of the numbers that you multiply. That's the last digit of the answer to the multiplication. So a very simple trick, and it's working just the same as for the squares and for the cube roots. Okay, nice. So how do we multiply numbers together? So you will have to do multiplications for the Mental Math World Cup. And the method I would recommend is called cross multiplication, or sometimes known as FOIL. So example, and I did this yesterday in the master workshop. So today I will do it quickly. I won't go into much detail because we did a lot yesterday. And I will give you a link to a resource on my website that has more information about this. So you can look at it yourself if you would like. So example, let's do 54 multiplied by 67. It's the same example that I did yesterday. And I will explain. So if you want to answer, you can, but I'm going to explain the methods here. So it's 54 multiplied by 67, and I'm going to give lots of space here. So the first thing I'm going to do is I'm going to multiply together the 4 and the 7. And this tells me that the answer must end in an 8 for the same thing that we just heard. So we have units, 4 times 7 equals 28. So this means I can write the digit 8 in the answer. So write 8. What's happening with the 20? The 20 is how many tens I've got. I've got 2 tens. So I'm going to carry that to the next stage. So at the moment, we know that the answer is going to end in 8. Tens digits, I'm going to start with the carry. I always start with the carry. I'm going to write this. Ooh, what the hell? Yeah. So I always start with the carry from the previous one, and then I'm going to expand this blocks to cover everything, and I'm going to have a look at this cross in the middle. So the 5 times the 7 and the 6 times the 4. So I do 5 times the 7, and so I don't get confused with the numbers, I already think of the answer. So I start with 2, I add the 5 times the 7, and I've got 37 in my mind. Then I do the other part of the cross, which is 6 times 4, and when I add that on, I get 61. So this means I have 61 tens. So I can write down the 1, and I can carry the 6 tens into the units. So the answer is now, I already have the 8, now I can put the 1 there as well. Now I have the hundreds, so I have the 6 that I carried, and I now move my box fully to the left. And how many hundreds? I've got 5, 5 times 600s, and that there is equal to 36. And now I can just write down the rest of the answer. So this method is called cross multiplication. You may have seen this in algebra class related to FOIL. There's a few different, it's also one of the Vedic sutras explains this as well. And this is how I recommend doing 2 digits times 2 digits. We start off looking at these ones. So actually, this is maybe easier to describe if I do it in different colors. So the pink is finding the units here. Then I'm going to have my cross in the middle. Let's do the cross in orange. And that will find me the tens. And then finally the hundreds. Let's do this in yellow. So I look at this afterwards. This works then for all 2-digit times 2-digit multiplications. When you see the questions, they're likely to be, well, no, they are going to be written in a single line. So 54 multiplied by 67. Let's add lots of spaces to this. Okay, so 54 times 67. How does the same method look in this example? So the 5 times the 6 is like this. The 4 times the 7 is like this. And then the cross is like this. And it's a bit like a face. It's a bit like a smiley face. We've got the nose between 4 and 6, the mouth between 5 and 7, and then 2 eyebrows. One of them is pink and one of them is yellow. So when I'm doing this, I first of all do the pink 4 times 7 to get the units, carry the tens left over. Then I look at the bottom. I do the middle ones, 4 times 6, and the outside ones, 5 times 7, whichever order I want. Add those with the carry, and that gives me the 61. And then to do the hundreds, I go to the left side of both numbers. So I'm looking at the 5 and the 6, and this then tells me the answer. So this is how cross multiplication works, and we have here 3 diagrams of how to think about it. I'll also give you a page on my website so you can read more about this in a moment. Let's just do an example together. So the example I want to do is, what is 43 multiplied by, let's do 56. So 43 times 56. Answers in the private chat, and you can say volunteer if you'd like to explain how you use this method for solving it. A question came through. Yeah, very good. What if we have to do this method with 3-digit multiplication or more? You won't have to do 3-digit times anything greater than 1 digit. I'll say something about 3-digit times 1 digit in a moment. Does this method work for like 3 digits times 3 digits? Yes, it does, but it's more steps, but quite simple once you learn it. I'll give you a link on my website that shows you how you can use the same method for doing multiplications of 3 digits, 5 digits, 8 digits, any number basically.
Hey Daniel, for Mental Math World Cup, we will have three digits by 3 digits. We also have
Okay.
Yeah, we do have 3 digits by 3 digits.
Okay. Thank you for informing us. Okay, so I'll explain.
For
Okay, I'll
for
explain next how.
Grandmaster and Zen Master.
Okay, yeah. The examples I saw didn't have, so I clearly didn't see enough of them. So okay, so I'll show you in a moment how we do this for larger ones like 3-digit times 3 digits. So a lot of answers coming in that are correct. So I'm looking for someone who has the correct answer and who would like to volunteer. Okay, and we try and pick as many different people as possible. So we're not. Okay, can we have Mia, please?
I got 2,408 because first I multiplied 5 with I got 4 with 56, then sir, can I write? Can I explain? Like, can I write on the board? Because I
Um,
also
easier just to explain rather than writing. So what did you start
I
with?
feel more comfortable writing while explaining. That's why.
Okay, I think best not writing, but it's okay, thank you. Yeah, for the I think it is possible to write on the board, but for speed we won't be writing on the board. Do you want to explain, Mia, or should we invite somebody else?
Sir, I got 2,408. Since first I
Good, yeah.
multiplied 4 with 56, which equals to 224. And then I multiplied 3 with 56, which gave 168. And now since we can't just put them together, like 224,168, since it'll become bigger than it's needed, I took the last 2 digits of 224, which is 24, and I added it with 16 from 168, and that's how I got 2,408.
Okay, so this is actually using a different method, but it's still valid. So, and this only works for small numbers, but we can totally do it. So here we did 40 times 56. We also did 3 times 56 to get 168. And then we add these together. And the nice thing is that the first number always ends in 0. So adding these together is really, this feels like doing 224 plus 160. And this gives the this gives us the correct answer then, 2,408. So this is an alternative method. It's not the cross multiplication, but some of you may also like to do this method. It's completely true. And Retif, can we invite Retif to also share a solution to this?
Morning, sir.
Morning. How did you solve this one?
So what I did is I got my pen and paper, and
Okay.
I thought 3 times 6 was 18.
Good, yeah.
So I wrote the 8 and carried on the 1.
Nice.
Then I crossed it, so then it was 3 times 5 and 4 times 6, which was 15 plus 24. And then we add the 1 that we carried on, which gives me 40.
Good, yeah. My recommendation for everyone is to always start with the carry. So at this point, I think maybe you do differently, but my recommendation is to start with the carry. And then at this point, I already have 16. And then at the end, I will get the same answer as you. What did you get?
I got 40.
Good, yeah. So we have 40 tens. So I'm going to write, what do I write?
So you write the 0 and carry on the 4.
Perfect, yeah, very nice.
Then I
And how
did
do
the
we finish?
Then the last line was the 4 times the 5.
Good, yeah.
And then I just added the 4, which gives me 24.
Good, yeah.
And then
So what's
and
your
then I
final
just
answer?
wrote 24.
Very nice, yeah. So we got the 8, we get the 08, and now it's 2408. Okay, very nice, cool. Thank you for sharing. So this is how we use cross multiplication, and we've also seen an alternative method that some people might prefer, which works for smaller numbers. Whereas cross multiplication works even if you do like 20 digits times 20 digits. So, okay, how can we extend this then for very large numbers? So you have to go up 3 digit times 3 digits. Let's just do 3 digits times 3 digits. So imagine I'm doing 234 multiplied by 567. So I write everything very big. So here is a lot of steps to write out, so I'm going to do it more compact. So I start again with the right, and if I just get my space, yeah, right. So I start with the units digits. Why is this not the color that I wanted? Here we go. So we start with the units digits, which is like before, 4 times 7 equals 28. So write 8. That's not how I spell. Write 8 and carry the 2. So far everything is the same. Now I'm going to get my digit that I carried. Oh yeah, maybe I can write the answer. So it's 8. So here I can get the tens, and then I can expand this in this direction. And then I'm going to do the cross, but I'm going to illustrate the cross in a different way. So I've extended this to the 6. So I'm going to think of the opposite side of the cross, and then I'm going to imagine that I'm moving this star in opposite directions. So it starts off with the 6 times the 4, like we had before. And in my mind, now I have 26 because I already add the 2. Then I imagine that the star moves one place. On the bottom, it moves to the right, and at the top it moves to the left. And then at this point, I'm going to have my 3 times 7, which is going to be 47. Just like before, I'm going to write that 7 and I'm going to carry the 4. So this is going to be something, 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 7, 8. So far everything is the same, but the hundreds is now going to get more complex. So I move this box. So I'm looking further. The star moves along the bottom, but now these arrows, they have to move further. These arrows have to move in opposite directions across the whole box. So I start with my carry, and now I have to do the 5 times the 4, which gives me 24, plus, and now imagine that the stars move to, I'll change the symbol, so they move to this position. So that's going to give me 6 times 3. Again, I'm going to get confused with all of the numbers, so I'm already going to add this on. So 24 plus 6 times 3, 18. 24 plus 18 is 42. And then finally, I move the stars all the way to the other side, and I end up with, let's put a heart here. So I end up with these ones. So 7 times 2. And that gives me 56. And now finally, like before, I can write the 6 and carry the 5, and the answer is something, something, 6, 7, okay, 6, 7, 8 in this case. So it takes some practice, but you're always looking at you're always doing it in this balanced way, finding the next two numbers that you need to consider, and then moving in opposite directions to find all of the others. At this point, of course, we haven't finished. So the thousands, we have the 5 that we carry, and then the box is going to shrink. I'm actually going to change the color of the box. So I'm going to do it like this so I can remove it later. So I'm now looking in this box. The opposite corners are now 5 and 3. Which gives me 20. And if I move to the other corners of the box, then I end up with the 6 times the 2, which is 32. Again, write the 2, carry the 3. And this should give me something 2, 6, 7, 8. And then we just keep on going like this. Now we're almost finished. We've got the 3 plus the 5 times 2, which gives me 13. So the answer is therefore 1, 3, 2, 6, 7, 8. I just check on my calculator to make sure I didn't make a mistake somewhere, and yes, this is correct. I'm going to illustrate with the symbols where these came from. So this was that bracket. This was that bracket. And this was that bracket. So the diagram on the left is showing you the 100 step, but you're repeating the same idea in your mind each time. How does this look like with the digits written out? So you will have your 234 multiplied by 567. So now I can do a diagram like we saw on the previous screen for 54 times 67. How is this going to look? I'll use different colors. So we start off with the, I will do it with the stars. Okay, so we start off with the stars above the 4 and the 7, and then we multiply them. Then on one of the numbers, we move the star across. And imagine that we're moving these now in opposite directions. So this moves from the 3 to the 4, this moves from the 7 in this direction, but we only, when we get to the 6, we can't go any further because 234 doesn't have any digit after the 4 to match with the 5. Then for the next one, we move the star to the 2. And again, we're going to move these in opposite directions to get um, the 4 times 5, 3 times 6, and the 2 times the 7. So you can imagine the same thing for these numbers written out in a line. So I recommend to practice using these methods to um, to multiply the numbers, and with practice you can get very fast. So as a demonstration, I'm going to show you. Oh, actually, I don't. No, okay. I can't do the demonstration because I didn't. I couldn't get the. I have a new laptop and I don't have the correct multiplication software installed. But when I practice this, I can do 3-digit times 3-digit, and it takes me about. I think it's about 12 seconds, and then 4-digit times 4-digit I can do in about 22 seconds. And the fastest people in the world, they can do 8-digit times 8-digit, and they get the answer in less than 1 minute using this method. This is more advanced than you need to know for the competitions, but you can see you can use this for solving any kind of multiplications, and with practice, very fast.
Yeah, and just for context for everyone, some of you may not have us looking at this for the first time and probably are thinking that this is too long, or it's not the way I am used to doing in school. But if your intent is to be a mental mathlete, all right, this is the way to do it so that you can do it mentally and not write it down and do it. So these methods that Daniel is showing is the psychology of how a mental mathlete thinks and how he solves the numbers mentally.
Good, yeah. Thank you, Avinash. So this is maybe what the more complex method that we've had a look at today. And I don't want to do like too many examples of this because it becomes not interesting for the workshop.
Yes.
So what I have is a link on my website which explains this method with, I think it's 4-digit times 5-digit. It's working the same way. It doesn't matter how many digits are in each number, presented in a similar way with different colors. And then you can try doing this yourself with a pen and paper to see if you can get the right answer. What else is there to say about multiplication? Not much.
I think we can move to the next topics, Daniel, if because
Yes.
we can have these on recordings for everyone, so they can come back and review this at their own convenience, and let's cover the other topics now.
Also useful, yeah. Okay. So the two main topics to cover now are division and then highest common factor and lowest common multiple. The last two, they come together. So I'm going to do division next. And my a big theme of this workshop we had with the cube roots and the square roots and the multiplication is that you can get some information from the last digits. So imagine I have a number that ends in 6, and I divide it by a number that ends in 7. What would be the last digit of the answer? Answers in the private chats. Also, I've just told you the answer. Let's do a different example. I have one that ends in 4. I divide it by a number that ends in 7. What would be the last digits? of the answer. So what's the missing digit? And I take a volunteer for this question. Okay, good. I've got some correct answers coming in, which is very nice. So I take a correct answer from someone who likes to volunteer. Okay, write the word volunteer if you'd like to. Yeah, we have number 67 lots of times today. It's a useful number. I'm still waiting for someone with the correct answer to this question who would like to volunteer. Okay, and can we have Ali Ahmad, please? Ali Ahmad.
Yes, sir.
Yeah, what do you
So
think the last digit is?
I think it's 2 because, as you said, for the second digit, last number is 7. So I can think that in the timetable of 7, eh, it's 7 times 2, which was 14. So I think the answer could be 2.
Good, yeah, and you're exactly correct. So it is 2, and we can look at the 7 times table. 14, 21, 28, 35. I'll write all of them out. 49, 56, 63, and 70. So here they all end in different last digits. And the only one that ends in a 4 is 14. And so this tells us that this must be the correct answer. So yeah, very good. Because we know then if we multiply a number that ends in 2 by a number that ends in 7, the answer would be a number that ends in 4. And the only way we can multiply a number by something ending in 7 to get something ending in 4 is 2, because all of these last digits are different. Let's try another example like this. So I've got something that ends in, let's say, 2. And I'm going to divide it by a number that ends in 8. And I want to know what is the last digit going to be. I'll give you a clue. It's a trick question. This is a trick question. Okay, I had the first correct answer. I'm waiting for a correct answer with a correct answer with someone who also wants to volunteer. Most people writing the same thing. I've only actually seen one correct answer. Lots of answers coming through. Only one of them is fully correct. 2 of them now. We have a second answer fully correct. I've responded to both of those that I've seen. Okay. All right. So could we have Alex, please? Alex SH.
Yes, hello. So the answer could be ending either in 4 or 9 because looking at the timetable, yeah. it's either 8 times 4, so that would be 32, or it would be 8 times 9, which would be 72. And since both of them end in 2, they're both possible answers.
Perfect, yeah. So we like this, we look at the 8 times table, looking for things that end in 2, and it could be 32 or it could be 72. So if those of you who gave the answer 4, it could be correct. Those of you who gave the answer 9, it could be correct, but we don't know which one. It could be either. So it could be ending in 4, or it could be ending in 9. So specifically, this could be like 32 divided by 8 is 4, or it could be like, to move this, like 72 divided by 8 is equal to 9. We don't know which one. So this is important for division, because when we're doing the division, we can look at the look at the other digits, which I don't show here, to have an idea approximately what the answer is going to be, and then we can get information from the right of the question to figure out which one it would actually be. As an example of this, I'm going to do one that's fairly fairly tricky. Yeah. So question, what would be this number divided by divided by 38? Again, I can take volunteers for this one. So what's the full answer? I've got a couple coming in. Can I ask Sanintha? Sanintha, please.
So to find out 3,268 divided by 38, I started from the left. So first I found out on how many 38s were in 3, none, so I left that blank. Then I found out how many 13s were in the number 32, also nil, so I decided to leave that blank. To find how much 38s were in 326, then I found out that that 38 multiplied by 8 is 304. So then I write 8 at the top, so that's going to be the 10th place. And then I minus 304 from 326 to get the remainder of 22. Then
Good, yeah.
I brought the 8 at the end of the dividend 3,268 to the 22, forming a new number 228. Then I'll find out how much 38s were in 228. And then I found out that 13 multiplied by 6 is exactly 228, and when I minus 228 from 228, I get a nil. So therefore, the answer to this division is 86 with no remainder.
Very good, yeah. Thank you very much for explaining, and the answer is 86. So working from the left, then you use, in this case, multiples of 38 to find what's the first digit going to be. And so we can maybe estimate it's going to be like 90 or 80 or something like this. So you find one of these, and this tells you what the tens digit is going to be. This takes a bit of work, a bit of thinking, but we find here the answer is going to be 80. And we also find that the remainder is 228. So the remainder is quite large. So compared to yeah, so the remainder is, I'll come back to that. Then working from the right, so Sanantha did this pretty much just by guessing the answer and checking it. Here we can say that the last digit must be 1 or 6 by looking at the 8 times table and seeing what ends in 8. 8 times 1 is 8, 8 times 6 is 48, so it's one of these. So we just need to decide which of these it's going to be. And because the remainder in this case is 228, we don't even have to do the division to check. 228 is not 38 times 1. It's much bigger than that. So it must be multiplied by 6, and we can just guess then that the answer is 6. So it's like with the square roots, we had two possibilities, and we just decide, is it the big one or the small one? Here we're doing the same. Is the remainder something big or is it something small? And then you choose the option. The other thing to note here is that for square roots, we had for the square roots for method 2, the options are symmetric. So if you have 1, you have 9. If you have 2, you have 8. If you have 4, you have 6. It's always symmetric around 5. Here it's different, that the options are always 5 away from each other. So if one option is 1, the next one is 6. If one option is 2, the next option is 7. And this is nice because they're always far from each other. And so the method for when you do the multiples of 38 for the division, this means that you can be lazy with the last step because it should be obvious. It should be quite obvious whether it's the smallest digit or the last digit. So this is the main tip and trick I want to show you for the divisions, which is by looking at the last digits, you will have, what am I saying? Yeah, by looking at the last digit, you will have either one or two options usually of what the last digit is going to be. So if you're dividing by a number that ends in 1, a number that ends in 3, a number that ends in 7, or a number that ends in 9, there's only one option, which is very nice. If you're dividing by 2, 4, 6, or 8, then there are two options, well, not really options, two possibilities. And they are 5 apart. What happens if dividing by 5? This is the tricky one. So if you're dividing by 5, then you end up with actually 5 options, which is very tricky. And this means you have to be more precise with the division algorithm because the left-hand side of the question is going to make it harder. So when you're dividing, the easiest ones are when the number you're dividing by ends in 1, 3, 7, or 9. And 2, 4, 6, and 8 is more difficult, and dividing by 5, this is most tricky. So this is my main tip and trick for the division methods. And
hey, Daniel, before you move ahead,
yes.
would you have anything to offer for remainders also for them? Is there any tip or trick for remainders?
So the remainder is for the it's just a subtraction at the end.
Yeah.
So in this case here, if we think it's going to be 80 something, you say what's 38 times 80, and yeah, and then compare it to that. There are some shortcuts I do, but they're I think they would be more confusing to explain.
All right.
So, but that does bring me very smoothly into the last thing I wanted to mention about division. And this is something that a lot of mathematicians get confused by or they don't know, but you will need to know this for the Mental Math World Cup because the exam uses the proper terms for the division. So if I have, I'll just pick a simple example. Let's say 100 divided by 7 equals 14, remainder 2. Each of these terms has a special name. Could anyone tell me what's the special name for the answer without the remainder? Does anyone know this? Begins with a Q. Couple people saying it. Yeah, Sanintha. That's it's just a one-word answer. I'll let you tell us. Yeah, Sanintha,
Sanita?
you're unmuted.
Sanita, you are unmuted. You can see the answer.
Yeah, Sanintha, we can't hear you actually. I don't know why.
You want to pick someone else?
It's okay. I'll pick myself for this one. It's
Okay.
a one-word answer, so it's the quotient is the answer. So the quotient is the biggest number that it divides into, and the part that is not fully divided. This here would be the remainder. What's the term in pink called? It's the things that we are dividing by. So answer in capital letters and say volunteer. So answer in capital letters for this one and say volunteer. So I know you're answering for the correct one. Okay, yeah. Oh, yeah. Now I see a lot of people had the right answer of quotients for that one. So answer in capital letters and say volunteer if you think you know what this one is. Okay, can we have Kartik? Kartik Saini.
Divisor?
Good, yeah. So this would be the divisor. So it's the number that you're dividing by. And you will see these words used if you're reading anything about mental math divisions. And also some of these words are used in the competition. And I'll just fill this one in myself. This one is the dividends. So the dividends is divided by the divisor, and that gives you the quotient, and there might be a remainder, or the remainder could be 0. So it's important to know these words, so I just remind you them here. Okay, that's everything I want to share here with the division method. The thing we kind of skipped over a little bit is the method working from the left. So I will, at the end of the workshop, I have a few little gifts for you, which are pages from my website that you can use for studying some of these things if we went over them too fast today. And one of them is a method for the division algorithm that actually allows you to divide by very large numbers. So that's a more complex method than you need for this, but if you want to learn something more advanced, then you also have that.
I think Daniel, you've used that method in one of our previous sessions, so we can share the
Also,
link for
yes.
that. Yes, we can share the link for that webinar also with the participants. We can have a look at that from there.
Yeah, there was one time we did like the full thing with the flag methods.
Yes.
It takes quite a lot of time to go through, but yes. Yeah, also a good idea, yeah. Let's finish then with highest common factor and lowest common multiple. And I have two very clear tricks for this. So first of all, what does highest common factor mean? It means the highest number that is a factor of both numbers. So for example, if I have, let's say, 150 and 90, common factors of both of these numbers, both of these are multiples of 10. So I can say, actually, 10 is a common factor. 2 is a common factor. So lots of these numbers are common factors. Actually, even 15, common factor. You can find some more, but the highest common factor is 30. So it's the largest number that divides into both of them. Both 90 and 150. And when you learn about these at school, they say find the full prime factorization. So 150 is going to be 2 times 3 times 5 times 5. 90 is 2 times 3 times 3 times 5. And then count the number of different prime factors. But this is actually a bit confusing for, it is not a very efficient method for mental maths. So I'm going to show you a special method which is based on Euclid's algorithm that simplifies it. So this is my method. So the quick trick method for HCF. Subtract the numbers from each other. Or any multiple of one number from the other number. This gives you a smaller number. So, example, I can do 150 take away 90, which gives you 60. You could repeat that more times if you want. Usually in these questions, it is not necessary. And then finally, find the HCF of the US number with one of what are the original numbers. So example, we want the HCF of, let's say 90 because it's smaller, and 60. And now it might be obvious that the answer is 30. So let's do an example using this trick, and I will think of an example which is where this trick is very helpful. So HCF of, let's do 102 and 114. So using the quick trick method, how would we find the HCF of those? And I also look for a volunteer. Okay, lots of incorrect answers actually. Interesting. Okay, I've seen one correct answer, lots of incorrect answers. Of course, I don't see everyone's answers at the same time, so you might have answered correctly. So the answer is not 12, and the answer, okay, now we have one. So Matthew Schultz. Can we invite Matthew Schultz? Okay, now I'm seeing more correct answers. Matthew Schultz.
Am I?
Yeah. How did we solve this?
I took 114, then I minus it with 102,
Okay.
and then I got 12, and the biggest FCF is 6.
Good, yeah. So the HCF must be it must divide into 12. So 12 must be the HCF must be of 12. So is it going to be 12? No, because 112 is not a multiple of 12, but it could be 6.
Yes.
So I can do HCF, for example, of 102 and 12, and that's easier to find that the answer is 6. Okay, very good. Thank you for sharing. Optional, I can also do an optional repetition. So here I can do 102 subtracting 96. Why 96? Because this is a multiple of 12, and this gives me 6. So the HCF must be a multiple of 6. And actually, yes, it's 6, because 102 divided by 6 is a whole number. And this is much easier than trying to find the prime factors of 102 of 114 and 102. I'll do one more example, and then I'll tell you a thing for the lowest common multiple, and then I will give you the bonuses. Then we finish the theory, and I give you the bonuses because that will then be the end of the workshop. So the next example is the highest common factor of, let's do 304 and how shall I do this one? 304 and actually I changed my mind. Okay, I will do 1001 and 98. So what would it be? 1001 and 98. I'll give you a clue as well. We can find the difference between these numbers, but it's more useful to find the difference between a multiple of 98 and 1001. Okay, this time the first person I checked had the right answer. Put the word volunteer afterwards if you want to explain. Okay, and can we have Rayansh? Rayansh to explain, please.
So the way I found this answer first was like I subtracted 98 from 1001, which I got the answer as 903. And one thing I noticed, like I didn't do exactly the same method as this one,
Okay,
but
okay, interesting.
I noticed one thing in both, that 98 was divisible by 49. So then I tried it out for 903, but it was not. And then I reduced from 49 to 7, and then I tried it on 903. When I tried 7 on 903, it was divisible. So I got the HCF as 7 in this way.
Okay, so in this point, it was almost like the question was too easy, and without even doing a big multiple, you found the answer. Very good. And so if you know the factors of different numbers, then it can help a lot. In this case here, the fastest shortcut is to take away 980, and this gives me 21. So the highest common factor then I can just do with 98 and 21. And what do I know about these numbers? They're both multiples of 7. One of them is 7 times 3. One of them is 7 times 14. Doesn't share any factors. So therefore the answer is going to be just 7. And this means I don't need to prime factorize 1001, which is maybe you know the answer, but it's more work to do that. So this is my big trick with the highest common factor. Let's finish then with my trick for the lowest common multiple. So if I have the highest common factor of A and B, where A and B are any numbers, and I multiply this by the lowest common multiple of A and B, the same numbers, this here is always equal to A times B. This is always true for any numbers A and B. Therefore, if I can calculate the HCF of the numbers, then the lowest common multiple of A and B is equal to A multiplied by B divided by the highest common factor of A and B, which maybe seems difficult to calculate because I have to multiply A with B, but I don't actually. Because here what I can actually do is I can divide A by the highest common factor of A and B, and then just multiply that by B. So this is kind of in algebra. So as a method, I can say find the highest common factor, divide one number by the HCF, but multiply by the other number. So let's try this. So what would be the highest common factor of 1001 and 98? Well, that's not what I meant. I meant the lowest common multiple. How do we find the lowest common multiple of these numbers? So this here is going to be, first step is find the HCF of 1001 and 98, which is 7. We did that before. And then the LCM of these numbers is then going to be 98 divided by 7 multiplied by 1001, which is just 14 times 1001, which is equal to 14,014. Maybe a bit of a crazy example because it was from the last one we did before. But yeah, Once I know the HCF, I can make the 98 smaller by dividing by the HCF and then multiply that by the other number, 1001, and this gives me the answer. This is so much faster than trying to find the full prime factorization of both numbers, collecting the prime numbers and multiplying together, which is what you would be taught in the textbook at school. This is a much nicer shortcut. So let's finish with an example of this. So use the shortcut to find the LCM of, let's do 125. That'll make it easier. 126 and 154. This is a pretty difficult one. Yeah, this is a pretty tricky one, but if you follow this method, it's actually not that hard. And again, I accept a volunteer for this one. Okay, we've got some correct answers coming in. Also say volunteer if you'd like to volunteer. And then the first time I see a correct answer with a volunteer, then we'll go with that. Okay, let's invite Alex back. Alex SH.
All right, so if we follow again the methods, so what we would get is so first we do 154 and then do minus 126.
Nice, yeah.
Yeah, and that will give us 28. However, if we were to check, so for example, if we do 154 divided by 28, we get 5.5 if we like do the full calculation. So obviously it's not correct. But the thing is, since it's 0.5, we know that if we divide it by 2, it'll give us a whole number. So we will do 154 divided by 14, which, one sec, gives us 11. So after that, we multiply 11 by 126. So 11 by 126. And that will give us 1,386, which is the lowest common multiple.
Very nice, yeah. Perfect solution. Very nice. So we first of all find the HCF using any method we want, and we now have the trick for the HCF. If the numbers are close to each other, we can just subtract them, and then maybe we have to check. Maybe it's not the first thing we find, but the second thing we find. The next thing we do is once we've got the HCF and we checked it by dividing, then we just multiply that by the other number, and that's already the LCM because of this special formula that the LCM is one of the numbers divided by the HCF multiplied by the other number. And in most cases, this is a very nice trick for solving the LCM. Okay, that's the end of all of the theory for today. So yeah, thank you for joining today and going through all of these methods, looking at the cube roots, the square roots, the multiplication. We see the importance of addition and subtraction through all of this. So everything you do practicing addition and subtraction is of course important, and division and the highest common factor and the lowest common multiple, which covers all of the more difficult categories that we have in the Mental Math World Cup. I'm gonna drop some links in the public chat, which are the kind of gifts from this. It'll take me a few moments to do that. Meanwhile, anything else, Avinash, we want to say just to finish for today?
Sure. First of all, Daniel, thank you for this wonderful session. I'm sure all of us over here have really found some amazing ways to look at these calculations in a different way from what we've learned in schools. So participants, as Daniel mentioned, he'll be sharing a few resources right now. We will make sure that the same is shared with all of you tomorrow, along with the recording of this session tomorrow. And also, with regards to your upcoming mock tests that is going to be happening between the 24th to the 27th, that is a practice test. Again, that's not in the scores over there are not going to be counted, so don't worry about how that will impact your qualification later. So the mock test is between the 24th to the 27th, and the round one of the Standard Mandatory Challenge is between the 1st to the 5th of August. So please prepare for that. Obviously, those who have made it to the top 200 of the Mental Math World Cup in 2025, or have been the top 100 in the GMMO Dubai or GMMO Mumbai or Bahrain Mental Math Olympiad in Mumbai, in Bahrain, will make it directly to the round two, the grand finale. So you will not have to go through the round one. Those who have made it to the top 100 in the Standard Mandatory Challenge. So I'm sure you must have received a communication about the same also. Just in case you have any doubts, just drop us a message on +91 8291027238, or drop us an email on contact@livemcl.com, and we'll be happy to answer any of your doubts regarding your participation.
And just to finish then with information about the bonus links. So I've put links to 5 pages from my website that are relevant to what we were doing today. And in fact, maybe I also do the, there's a 6th one I'm going to add, if I can find it. Yes, this one here. So six little bonuses from my website. I'm just going to share my screen and show you me using a couple of these. So first of all, I have a way of practicing the small multiplications that we did today. So screens, basic multiplication trainer. You have the link to this in the chat. So if you want to practice 2-digit times 2-digit multiplications, or even smaller ones, this is how we use it. You press enter, you try and solve these in whichever way you're going to do. And so in this case, if I can do maybe the 8, carry the 1, 22, 46, 4, carry that, 3, 2, 4, 6, 8. Or maybe in this case, maybe there's a different trick that I want to use. So I'm going to do 258 from that, 4042. So there are some other tricks you might know for multiplying these. Every time I'm just pressing enter, I have the question here, and I type in the answer as fast as I can, and it tells me what my average time is and what I did for each of the questions, and if I got any of them incorrect. Let's get one of them incorrect. So I type in this one, it goes orange, and it tells me what I got wrong. So this is one extra tool, as well as all of the apps that Live MCL has provided, you can use for practicing the multiplications. And the other one is, if I just find, I have it somewhere. I have the flashcards tool. Yeah, here we go. Somehow I sent you the link but didn't have it open on my computer. So this is a flashcards tool, and the way you use this is slightly different. So you pick something you want to practice. So let's do the cubes. So I type the answer and press enter. I type the answer, it gives me the same one again. Press enter, 64, 3375, 512, and so on. If I get one wrong, actually I've forgotten that one, 2197, then it goes orange. There's actually a timer for 30 seconds happening in the background. It's not happening now because I'm between the questions, but it's happening when I'm answering the questions. And this means that at the end, that's a typo, at the end, it's going to tell me how many I got correct. So the idea of this is that you can practice quickly getting the answers from memory so that when you need them in the competition, then you don't have to worry about remembering them. So it's an alternative to spaced repetition software. So in this case, apparently, maybe I should practice my 13 because I forgot that one, and I was slow at answering 12. I think that's just because it's difficult to type. And this one was incorrect. That was a typo. So this is a couple of tools you can play with these. Feel free to enjoy those. And that is the end of everything that I have to share today. Thank you very much for joining. Hope you have enjoyed and learned some things during this. And yeah, good luck for the competition itself.
Yes, and I'm sure everybody has learned a lot. And as I've mentioned earlier, it's all about practice. You have to go ahead and go back and implement all of the learnings over here. You will be having access to the recordings. So go ahead and watch it as many times as you want, and start preparing. As I mentioned, the mock test comes up for the Standard Mandatory Challenge between the 24th to the 27th. The details will be coming to you on the WhatsApp community groups. If you've not joined it yet, please make sure that you do. It has already been emailed to all of you, the WhatsApp community links. If you do not have it, reach out to us on contact@livemcl.com or drop us a WhatsApp on +91 82910 27238. All right. With that said, Daniel, thank you so much for your time. It was really awesome to have you here, and we look forward to our collaboration for the future as well. Thank you, everyone. You may all now start logging off and enjoy the remaining of your Sunday. Thank you so much. You really are wonderful, and you all deserve the break that you're going to get now. Bye bye. So you can log off, everyone. Thank you. Bye. 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 Bye, Ashwin. Bye, Aisha.